So about persistence of vision, we need to know. See, what is persistence of vision? If I want to tell you that about that thing, okay, then I need to give you an example. Sir, have you heard about the superhero Flash? Hello, do you know about Flash, the superhero?
Yes, sir. Yes, yes, sir.
What?
Yes, sir.
Which power he have? Which power he has? Sorry, no, I couldn't hear. Krishna, do you know which power Flash is having?
He generate light, sir.
Okay. Apart from that?
No, sir.
Apart from that, Flash is very, means he can run with a high speed, with a huge speed he can run. Okay. Means suppose if Flash is there, then suppose Flash is standing here, okay, or sitting here. Okay, suppose if I am sitting here, okay, then in that case, if I means move, then you can see that I am moving, right?
Yes,
you can
sir.
see I am moving. But let me tell you, if I can do this, means suppose I went here, then I came here and I came back, okay? And if during this time, means to do this, to go that side and to come back this side, if I take 0.1 second only or lesser than that, then you will not be able to recognize that I have shifted and then I came back. What it will look? It will appear that I am at the same place. Understood or not?
Yes, sir.
It will appear that I am at the same place. Okay. So see, this is known as persistence of vision. Persistence means what? The inability. We have one inability that suppose whatever you see, no, whatever you see, that image, that effect of the image, okay, it remain on your brain for 0.1 second. The effect of that image remain on your brain for 0.1 second. Even if the image displaced, even if the image got displaced, still its effect will be there on your brain, on your mind for 0.1 second. It means I have 0.1 second to cheat. Okay. Suppose if I am at this point of time, if I'm standing, if I'm in front of you, then this image will be there on your brain. The effect will be there in your brain for 0.1 second, right? So by 0.1 second, if I go somewhere and I come back within 0.1 second, you will not be able to recognize that I moved from here and I came back, isn't it? Isn't it? So this inability that whatever we see, that effect remain on our brain for 0.1 second, this is known as persistence of vision. Am I clear, students? Am I clear? Am I clear?
Yes, sir.
So see one thing here, what is told that the persistence of vision, the image of any object seen persists on the retina for 1/10 seconds. It persists on the retina for 1/10 seconds, means 0.01 second. Understood or not? And see, even after removal of the object, okay, this is known as persistence of vision. Understood? Understood? And let me tell you, this property is used in cinematography, means in movie. What happens with a huge speed, many frames, many picture frames actually move. And we don't understand that they are pictures. It appears that they are moving. Understand? So this is known as persistence of vision. Let's come to the next. What is that? Next is the defects of vision. Okay, no? Defects of vision and their correction. What are the defects of vision? First, we need to know. Okay, the first defect, what we will know, that is known as myopia or short-sightedness. What is that? Myopia or short-sightedness. So, see, if a person is short-sighted, okay, it means the person's sight became short. Sight became short means how much the person can see, that became lesser. That actually became lesser. Okay. So suppose if with a bare eye, means without using any spec, what you can see. Suppose if a bus is coming from a long distance. Suppose any bus is coming and you want to see the number of the bus. Okay, you will be able to see it. Means at the front of the bus, a number is written like 12AD or SD27, okay, or something mini. Okay, no? In Kolkata, many buses are there, bus service are there. So we can see that which bus is coming from a long distance, isn't it? So that is that if our eyesight is absolutely fine, then we will be able to see from a long distance. To see this from a long distance. But if we are having myopia or short-sightedness, then what will happen? We will not be able to see those things. From a long distance, the bus number we will not be able to see. From a long distance, if you went to the movie theater, then the movie will become a bit blur. Okay, no? It means you are having myopia or short-sighted. Or suppose you are sitting in the classroom and without using a spec, you will see that whatever teacher is writing on the board, it is appearing blur. Understood? So this is the problem. This is the difficulty in case of myopia or short-sightedness. Am I clear? Now we will know about these things, okay, in a proper way. See, just a moment. Now let me show you in the board. Defect of eye. The first defect is, first one, myopia or short-sightedness. Now, if we want to know the reason that why this thing happened, then see, The reason of myopia, see, the eyeball is too long or lens too spherical. The image of distant object is brought to focus in front of the retina, is out of focus, again before the light strikes the retina. Nearby object can seem more easily. Now see one thing. If I show this thing, the reason is what? The main reason is eyeball become too long. Okay. See, the eyeball become too long. That is the reason of myopia or short sightedness. Okay. Now, see one thing. This is the first reason that eyeball become too long. Second, also we can say that the eye lens, this is the reason number one. The second reason, eye lens become too spherical. Now, due to these reason, what actually happened in case of myopia, that I will show you. Okay. Let me draw the diagram. See, I'm just drawing over here. Okay, this is the eye. This is the eye lens. Now, light rays from long distance falling on the lens. Now, see, for a normal lens, what actually happened for a normal lens? After it fall on the lens, then it converge on the retina. Okay, it converge on the retina. This happens in case of normal eye. And when it fall on the retina, then we can see the object. Understood? Means there is an image of the object at infinity will fall on the retina, and we will be able to see the object. Means the image will be seen. The image will fall on the retina. Am I clear, students? This happens in case of normal eye. Now I will tell that if it is a myopic eye, then what actually happens? See, than a normal eye, the myopic eye become a bit more long. A myopic eye became a bit long. This eyeball becomes a bit long. In that case, if this is the eye lens, if this is the eye lens, then if these are the light rays falling on the retina, then what will happen? After refraction, it is converging before the retina. Understood? It is converging before the retina. Then what will happen? On the retina, a blur image will form. See, a blur image will form on the retina. Understood? Understood or not, students? So this actually happens in case of myopic eye. In case of myopic eye. So this is in case of normal eye. This is in case of myopic eye. Now, in that case, actually what happened? See, actually we should, means if there is a proper eye, means if it is a normal eye without any defect, in that case, we should see object at infinity. But in case of a myopic eye, since the object from the infinity doesn't fall on the retina, so one blur image formed on the retina. So object from a high distance, it slowly becomes more blur. And if the object is coming close, object is coming a bit closer, then we are capable to see it. Why? That I am also showing you. In that case, if the object came a bit close, in that case, what happened? The light rays, it is a bit more diverge no, than the parallel rays. So a diverge rays, it has more, it get actually more length to fall on the retina. Okay. So when actually the object come closer, at that time we are capable to see it. Understood or not? Students, am I clear or not? So
Yes,
actually what happened? We see actually our normal range is what? From infinity to 25 centimeter. The object at infinity we can see, and the object which is 25 centimeter, means at a 25 centimeter distance from our eye, that we can see. But in this case, what happened? The sight became less, means the infinity portion we are unable to see. So sight became short, no? From infinity it became short. So that's why it is known as short-sightedness. Our sight becomes short than infinity. Understood? Shorter than infinity. Okay. So this is known as myopic eye. Now I will tell you about the correction. How we correct it. Okay. See, if this is the myopic eye. This is the myopic eye. Now what we do, we just put, now we just put a concave lens. What we put? A concave lens, means in our spectacle, in our glass, we keep a concave lens. Now, concave lens is what kind of lens? A converging lens or a diverging lens?
diverging lens.
Diverging lens, right? Now, see one thing. If light ray from infinity is coming, light ray from infinity is coming, then once it fall on the concave lens, what will happen? It will diverge, isn't it? It will diverge.
Yes, sir.
So if it is diverging, it will diverge like this. It will diverge like this. Okay. So once it diverged a bit, then it don't fall behind the retina, it fall on the retina only. It will fall on the retina. Am I clear? Am I clear, students?
Yes, sir.
So this is the correction. So in our notes, we can write that correction is what? Correction is what? Having a glass of concave lens. Having a glass of concave lens. Am I clear, students?
Yes, sir.
But let me tell you, not of a suitable focal length. Okay. Of a of a certain focal length. Of a certain focal length. Understood or not?
Oh, yes, sir.
Great. So this is the myopia. Okay, we understood myopia.
Mhm.
So correction is putting a concave lens. Okay. Now we will come for the next, which is known as hypermetropia. Hypermetropia. Call it hypermetropia. Also, we call it as farsightedness. Hypermetropia or farsightedness. Okay. What is farsightedness? See, that was myopia or short-sightedness. There, what happened, students? What happened? Our sight became short, right? Means the far objects is not clearly visible to us. Similarly, hypermetropia or farsightedness is the opposite thing. Is the opposite. Means the things which is closer, we actually face problem to see it. We actually face problem to see. Means, as an example, like to read a book, we face problem. We face problem to read a book. So that is not clear to us. Okay. And let me tell you, in most of the cases, hypermetropia or farsightedness happen after a certain age, means 35, 40, like that. But myopia can have at any age. Okay. Now let me tell you one. See, like here, how we have learned that reason first. First reason. What can be written? The eyeball become short. See, in case of myopia or short-sightedness, what happened? Eyeball become too long, and in this case, what happened? Eyeball become short. Okay. Now, what is the correction? How to correct? What is the correction? See, in myopia, what was the correction? In myopia, what was the correction? Students, in myopia, what was the correction? See,
The islands became too spherical, sir.
no, correction. How we correct it?
Or having a glass
Of concave lens, right? See,
of
concave lens.
confidence or
Now
divergence.
here it will be having a glass of convex lens of certain focal length. Okay.
Yes, sir.
Now I will show you that means how I have shown in case of normal eye, that too will remain absolutely same. That also I will show. Let us consider the first. I'm showing you the normal eye. What happened in case of normal eye? For normal eye, see what is the least distance of distinct vision? Do you remember? What is the least distance of distinct vision?
Which one, sir? That long one ki that short one,
No,
sir?
least distance of distinction.
The
Least.
25 centimeter.
Exactly, 25 centimeter, right? So let us consider this is the 25 centimeter, the least distance of distinction, and from here, when light is coming, light is falling on the eye lens. So it is a diverging rays. So the lens is actually converging it on the retina, and we can see the diagram. We can see the
Yes.
image. Okay. So this is this happened in case of normal eye. Now, what actually happened in case of myopic eye? For myopic eye, sorry, hypermetropic eye, what happened? It is already told that the eyeball becomes short. Eyeball became short means, see, suppose eyeball became short like this. Okay. Now, in that case, if this is the lens and this is the least distance of distinct vision. Since the eyeball became short, it means what? Before this length was more, now this length is less. Means if you object distance is same, focal length of the lens is also same. So here the image distance got less, isn't it? Image distance became less. In that case, what will happen? The lens is not capable to converge the image, converge the rays on the retina. What will happen? It will fall behind the retina. It will fall behind the retina. Am I clear? Students, am I clear? So this way the light will fall, see, behind the retina. So obviously on the retina there will be a blur image. You will not be able to see, the light rays, the letters on written on the book. Okay, it will be blur. At that time, what you do, that I will show you. Means without using spec, what you do. Okay, when you suppose you are just started having problem, so at that time what actually you do, that I will show you. So this is what hypermetropic eye. Hypermetropic eye. I can tell you a way through which, if in your family, if someone is started having hypermetropia, okay, no, in that case you can see with a small observation, you can understand with a small observation. Do you know what? Do you know what is that?
No,
Let
sir.
me tell you. Achha, suppose like if any one of your parent or any uncle or anyone, any auntie is maybe 35, 40, something like that age, okay, you will see if he or she is reading a book or reading a newspaper, no, he's not reading like this, he's taking the book a bit away, or he's taking the newspaper a bit away from him, like this he's reading. Okay, you see there is an abnormality. I means you will see that I also don't read like that, I read like this. We read like this, we read, isn't it? But someone is reading like this, skipping like this. Why? It means that person started growing hypermetropia. But when you started growing hypermetropia, at that time, why we do so? That I will show you. See, if I take, since our least distance is 25 centimeter for a normal eye, but for a hypermetropic eye, if you keep at 25 centimeter distance any object, then that image will form behind the retina. In that case, what we do, we keep the object away from the eye. We keep that object away from the eye. In that case, what happened, that I will show you. In that case, that same light ray from that same point, okay, no, when it went away from our eye lens, it actually it is less diverging, isn't it? Why? How you will understand that it is less diverging? Think about this angle and think about this angle. Which one angle is greater? Which angle is greater? This one or this one? The before one or the after one?
After one, sir.
After one is greater or after one is lesser?
Sir, greater, sir.
See it properly. As I let me show you here from here. Okay. Suppose one is this one and the other is this one, and one more else also I will show you. The other one is this one. Now let us consider this is del 1, this is del 2, and this one is del 3. Now you tell me which angle is the highest here, greatest?
Angle
Most.
3, sir.
Angle 3 is highest?
Yes, sir.
Think it properly. See this angle, and this angle. This angle, which one is highest? So if I draw it from here also, let me draw it from here also. In that case, now see the angle. Is this part is high? Is this part is more? Or this part is more?
Sir, L1 is more, sir.
Del 1 is highest, right? So del
Yes,
1
sir.
is the highest, then del 2, then del 3, and if you take it as del 4, then del 4. So the more away the light ray will move, the more it will be, means it will be less divergent, isn't it? The closer it will remain, it will be more divergent, isn't it? So when we keep the newspaper or the book away, it becomes less divergent, and for the lens, it becomes then easier to converge on the retina. Means it's very simply, it goes like this. Like this, it fall on the retina. That is the reason that we keep the newspaper, someone keep the newspaper abnormally away from him. Understood? Am I clear?
Yes,
Students,
sir.
am I clear? Shall I erase this part? This part I'm erasing, okay?
Mm-hmm.
Now, so now I will tell you the correction, okay? I will tell you the correction. What we keep, how we correct, we keep a convex lens, right? So if I draw it over here, so this is the lens. Now, if with the spec, means suppose we are keeping the spec, the lens in front of the eye, means like how we see a glass, okay? No? In that case, if I keep the object at least distance of distinguishing, means at 25 centimeter only, for that light first will go where? First it will go where? On the first lens, on the glass lens, isn't it? Then from there, due to this convex lens, what will happen? It will converge. It will converge a little, isn't it? So when it converged, a little, then it falls on another convex lens, and from there it converges even more. Understood? And it fall on the retina. Am I clear, students? Am I clear? In this way, we correct the hypermetropia. This is the correction. Understood or not? Am I clear? Students, am I clear?
Yes, sir.
Great. So this is all about hypermetropia. Okay. See here. If we are having hypermetropia, okay, sorry, if we are having myopia, we are having what? Myopia. Okay. Now, in case of myopic eye, as I already told you that we use what? A concave lens, isn't it? This is a corrected myopic eye. Corrected myopic eye using a concave lens. See, suppose the person can see maximum distance x meter. The person can see maximum distance is how much? X meter. Means till here, if any object comes here, that the person can see. But what the person wants to see? Object at infinity. Understood? Object at infinity. Thus, if the eye is to see a distant object clearly, concave lens should form a virtual image of this distant object at a distance x. Means any object, whatever is at infinity, what the concave lens will do, it will bring the image of that distant object at this point, okay, where the person can absolutely see. Okay, so the concave lens will make what? Every object at infinity at this point. Okay, so what can be written? See, like u is equal to minus infinity, and if this is x, okay, if this is x, then v is equal to minus x. Then what should be the focal length of the concave lens? See, if I use this formula, 1 by v minus 1 by u is equal to 1 by f. So 1 by v is equal to minus 1 by x. 1 by u means plus 1 by infinity. Now 1 by infinity is how much? Do you know? 1 by infinity is how much? 1 by infinity means 0. Something by infinity means 0. Okay, something by 0 is infinity and something by infinity is 0. In that case, we can write that 1 by f is equal to minus 1 by x. Okay, so as we know that 1 by focal length is power, so power is equal to minus 1 by x. So we can even write that p is equal to minus 1 by x. Am I clear? Am I clear? Okay. Hello, students, am I clear? Hello, students, can you hear me? Hello. Hypermetropic eye. Okay. See, in case of hypermetropic eye, what we need to do, that I will show you. Okay. See, a normal person, okay, no? A normal person who don't have any, who has a proper eye, who don't have any illness, any farsightedness, neither short-sightedness, nothing is having. So the person can read any book from this distance, 25 centimeter. But when the person is hypermetropic, at that time, his near point actually went away than 25 centimeter, isn't it? Is this y is greater than 25 centimeter, like this? See, this is 25 centimeter, the near point, and this is the y. Okay, now this is the y. Am I clear? Students, am I clear?
Yes, sir.
Now see here. So this focus or the power of this lens, how it should be, how much it should be, that we need to find. Okay, let's see. See, here what we need to do. We need to keep the book over here, isn't it? We need to keep the book over here, means the object over here. And where the image should form, at this point the image should form, because from here only we can see properly. Means any book you will keep over here, object you will keep here, and the image will form at this point, isn't it? Understood or not? So the object distance should what? It is minus 25 centimeter, because this is the position where I want to keep the object, isn't it? I want to, because, but since I am having hypermetropia, that's why I can't. Okay. So in that case, u is minus 25. Okay. Let us consider v is minus y, and f we will find. Okay. If I am using the formula 1 by v minus 1 by u is equal to 1 by f, in that case, 1 by u is minus 25. So 1 by v means minus 1. Or I'm just keeping it 1 by v only. 1 by v plus 1 by 25 is equal to 1 by f. And this 1 by f is equal to p. So we can write p is equal to 1 by v plus 1 by 25. Now, this 1 by v will be equal to y, isn't it? Now we will put it over here and we will get the answer. Understood? Understood or not? Okay. Now, let's do it. Let's do some numericals. See, if you see this question, what is told in this question that what is told that let the far-sighted eye, yeah, can see a minimum distance y. Okay. That is near point of the eye. The eye is to see clearly an object at least distance of distant vision 25 centimeter. I wants to see. Where I want to see? At 25 centimeter. Then u is equal to what? Minus 25 centimeter. V is equal to what? Minus y. Then f will be equal to what? We will use that formula. See, 1 by f is equal to 1 by v minus 1 by u. So 1 by v is minus 1 by y, and minus u is minus 25. So what we will get? 1 by f is equal to 1 by 25 minus 1 by f. So p is equal to what? 1 by 25 centimeter minus 1 by y. Understood or not? So this will be the power. What we got, that also written over here. Understood? Is that given with a, means like a problem. Understood? Clear? Students, clear? Hello? Is it clear, Krishna and Oishani? Okay. Now coming for the next. Now the next one we will know, which is known as presbyopia. What? Presbyopia. What happened in case of presbyopia? If we are having farsightedness and nearsightedness, okay, means myopia and hypermetropia together. Myopia and hypermetropia together, okay. Then it is known as presbyopia. Means this was what myopia was what when the far side become short. Hypermetropia is what when the near side become far. Okay, so I'm just writing over here. Myopia or short sightedness is what when far side become short. And what is hypermetropia? When the near side become long or become far. What is presbyopia? When together we are having myopia and hypermetropia. And hypermetropia. That is known as presbyopia. Means neither we can see the number of a bus, nor we can see, means nor we can read a newspaper properly. Okay, understood? Clear? So reason is what? Decrease flexibility of eye lens decreases. So neither it can become means properly thin, nor it can become highly bulged. Okay, so that's why this thing happened. Okay, now the remedy is what? Remedy or correction? Remedy or correction? Bifocal lens. Bifocal lens. What does it mean? Like you will see those who are aged person, no, they use that bifocal lens. Means if this is the if this is our lens, okay, our spectacle, then this is the lens. Here it is convex. Here it is convex, and in this place it is concave. Why? When we read like this, no? We read a bit bottom, okay, no? So suppose we keep our book here and we read like this. So that's why this place is convex lens to read the books. And when we see far away, we see like this, so we see in front, okay, no? That is the concave, okay? Understood? So this is the bifocal. So this is known as presbyopia. Understood? Clear? Okay. In case of astigmatism, what happens? Let me show you. Now the fourth one, which is known as astigmatism. What is that? See, in this problem, we can't focus horizontal and vertical lines together. If any, suppose signboard, in signboard lines are written horizontally also, lines are written vertically also. If we find this kind of problem that when we means together we can't focus the entire thing, means if once I want to focus the horizontal line, then the vertical line is looking blur. Okay, no? In that case, it is astigmatism. Okay. Reason is what? Reason if eyeball is not perfectly spherical, it means it is astigmatism will happen. Okay, and the remedy or correction, in this case, what we do, in this case we keep cylindrical lens. Okay, means and the cylinder, we keep it like this. Cylindrical lens, it becomes like this. Now it has different radius of curvature vertically and different radius of curvature horizontally. So what happened? Different radius of curvature, due to different radius of curvature of horizontal and vertical, the problem actually gets solved. Understood? Understood. So this is all about astigmatism. Okay, students clear? Students, am I clear?
Yes, sir.
One more problem is there, okay, which only happen when the age is more than 45, 50 like that, okay, or maybe even more than that. Okay, that is known as cataract. See, actually, what happened in cataract, let me tell you. A translucent protein membrane form on the retina. No, from not the retina, from on the cornea. Form on the cornea. Okay, and due to that, what happened? For that reason, the vision become blur. Understood? Vision become blur due to that reason. So that's why that is known as cataract. And let me tell you what is the and reason is old age, nothing else. Reason old age. By age, this thing happened to everyone. Okay, no? Old age, and that's why no students in many places you will see there are means without giving any, they operate cataract as a charity, like many association, they operate it without any price. Okay, no? They don't even take any price. And see, so most of us, it will happen with most of us. Okay, it will happen due to old age. Okay, now the remedy or correction is what? Remedy is what? Operation. There is no other remedy. And nowadays we do laser operation. Okay, it's like when my father, he was having his one cataract operation, one eye cataract operation. Okay, no. At that time, means first he was having problem. His vision was becoming blurred in the left eye. Okay. So when we consulted doctor told that cataract. So we need to operate, and it was a 1-day operation. By that day only, he was released from the hospital. Okay, after the operation, and means what they do, that membrane, no, the translucent membrane, they peel it off. They peel it off. Okay, no, from the cornea, and when they peel it off from the cornea, how they peel? Using laser. Okay, so they do laser operation. Okay, and let me tell you, see, when a skin will be peeled off from your eye, definitely the eye will bleed, isn't it? So that's why almost 7 to 15 days there will be bandage on your eye. Understood? So that is that. Okay. So these are the 5 basic problems or illness what our eye have and their correction. Understood? Clear? Am I clear, students? See, the question is this one. Okay, this one is the question, or just a moment. Okay, so this is the question. Let's see the question first. Okay, what is told? A man who wears the corrective lens of power 3 diopter. Okay, so what is the power of his lens? 3 diopter. Has to hold a newspaper at 25 centimeter away to see the print clearly. Okay, how far away would the newspaper have to be if he took off his corrective lens and still wanted a clear vision? Okay, see, with the 3 diopter lens, he can keep the object, he can keep the lens, sorry, he can keep the newspaper at a distance 25 centimeter. Means what is the object distance? Can you tell me? What is the object distance? See, if I draw it over here, small, yeah, what are the, at what this 25 centimeter? Very good, 25 centimeters. So the u should be 25 centimeter, right? So here we will write u is equal to minus 25 centimeter. Understood? Now, in that way, where the image will form, v is equal to what? So for that we need f also. How we will find the f? As we know that power is equal to 100 by f if f is in centimeter. So f is equal to 100 by p. So f is equal to 100 divided by p means 3. It is 100 by 3, this much centimeter. Okay, I'm keeping it like this only. I'm not calculating. Okay, because we will calculate at last. Now, see, if I want to find the v now, so 1 by v minus 1 by u is equal to 1 by f. So 1 by v is equal to 1 by f plus 1 by u. So 1 by v is equal to 1 by f means 3 by 100 plus 1 by u means minus 25, right? It will be minus 1 by 25. So if we do the LCM, so it will be 100 to 3 minus 4. So it will be 1 by v is equal to 3 minus 4 by 100 means v will be minus 100 centimeter. V will be minus 100 centimeter. Now, it means, just a moment. Yeah, it means that V is equal to minus 100 centimeter. Means what is her actual, means using the convex lens where the image actually will form at a distance 100 centimeter from the eye lens, isn't it? From eye 100 centimeter. So if we, by removing the convex lens, by removing this lens, if you want to see a clear picture of the newspaper, then where he need to keep? At a distance 100 centimeter. Understood or not? Understood or not?
Yes, sir.
That's it. Let's do the next question. Okay. What is told over here? See, it is told that what should be the focal length of a corrective lens required by a person for reading book if his near point is 90 centimeter. If his near point is 90
19
centimeter.
centimeter.
So here, what should be the focal length? Means you need to find what f is equal to question mark. Now see one thing, if this is the lens, see at this moment I will recommend you always to draw the diagram. That will actually clear your picture. A simple diagram of eye. This is the lens. Okay. Now see, he will keep a convex lens. Where he want to keep the object at a distance 25 centimeter. Okay. At a distance 25 centimeter, he want to keep the object. But his actual sight means by removing his near point actually became where? Here at 90 centimeter. Okay. So here what will be U and what will be V? If you get it, your job is done. Your means numerical is over. Okay. After that only calculation. Tell me what will be U here and what will be V here. Where he is keeping the object, that will be U. So where he want to keep the object? Where he want to keep the object? The newspaper.
Wait, sir.
Sorry, where?
Sir, wait 1 minute, sir. I will solve that.
No, you just tell me, no. After one by one, you tell me, and then we will proceed like that. Okay. By that also we can solve. Tell me that at what distance, means what will be the object distance where the person wants to keep the book. See, the person will keep the book or the newspaper like here. No, he wants to keep it at 25 centimeters. So U is equal to minus 25. So one thing I am telling you, take it as a note for short-sightedness. Sorry, for long-sightedness or for hypermetropia. I'm writing it for hypermetropia. Always U will be minus 25 centimeter. Okay. So U is minus 25 centimeter and V is where the image will form. At this point, the image will form. Here the image will form and here is the object. So V is equal to what? Minus 90 centimeter. Now solve it. 1 by F is equal to 1 by V minus 1 by U. So 1 by F is equal to 1 by V means minus 1 by 90 and plus 1 by 25. So 1 by F is equal to, now we need to do the LCM. Okay. Let's make it 900. Let's do. Okay. Let the LCM make it 900. Okay. So 900 into 25 is 90 90 into 25. Yeah. So if the LCM is 900, so 900 divided by 90 is equal to 10. So we can write it minus 10 plus 900 divided by 25 is equal to 36. So here we can write as 36. Okay. So F can be written as just a moment. So it is minus 90, right? Sorry, it is yeah. Then it will be minus 90 only. So 36 minus 10 will be 26 by 90. So F will be 900 divided by 26. 900 divided by 26. So 900 divided by 26 means 34.62. This much centimeter will be the focal length. Understood? Am I clear, students? Am I clear?
Yes, sir.
Okay. So that was it. Okay. Clear? So 34.6, something like that. Okay. So that was it, students. So now